Now, just to get a little bit more practice, let's go through a few more example problems, just so that we can feel more confident about this concept of multiplicity. And just like the last problem, we have a polynomial p that's graphed, and we need to find its equation. And like the last problem, we're going to start by first figuring out when the polynomial is equal to 0. So it looks like when x is minus 2.5, which we could write as minus 5/2. And since it goes through, that's going to have, we can say, multiplicity of 1. And for multiplicity of 1, I'll just write m1. Or for multiplicity of 2, like this one, I'll write m2. Now, the 0 for this one looks to be when x is -1. And since it just comes down and touches this and goes back up rather than going through, we know that that would have multiplicity of 2. And likewise, for this last 0 here, this is when x is equal to 3. And again, it's going to come down and touch the 0 there, the y value of 0, but it's not going to pass through. So that's going to have even multiplicity. And for all of these example problems, we're assuming that the multiplicity will be 1, 2, or possibly 3, but I don't think any of the examples actually cover 3. So just to make it simple, since it's fairly difficult to determine between multiplicity of 2 and multiplicity of 4 just by looking at the graph, since a quadratic and a quartic look very similar, one is just steeper than the other. So with this in mind, let's see if we can come up with the equation. So our polynomial p of x, we can write our linear factors now. So at minus 5/2, that's a little bit more difficult. So we're going to undo this equation and set it equal to 0. So let's start by multiplying each side by 2. And then we can add 5 to the other side. And so that's one of our linear factors. The next one will come when x equals -1. So that will have to be x plus 1. It's always the opposite value when it's an integer at least. And for this last one, we have x minus 3. And if you're not certain if this is the right equation, just check by plugging in your zeros and see if the polynomial does equal 0. For instance, plugging in a 3 here makes this 0. -1 here makes this 0, and minus 5/2, the 2's cancel, and you get minus 5 plus 5, which is also 0. And at this point, we just need to deal with this multiplicity. And multiplicity of 2 for this x equals -1, we're just going to square that. And again, for this x equals 3, this multiplicity of 2, we'll just square this as well, since each of these are what we call double zeros. So now, going with our equation here to try and figure out which one of these is correct, we know 2x plus 5 has to be linear, so it can't be that one. And we know that x plus 1 and x minus 3 both have to be squared. So in this one, the x minus 3 is not. In this one, the x plus 1 is not. And so that leaves us this one, which matches up perfectly with what we have, just the order is different, but that doesn't matter. So choice letter A is the correct answer here. And let's just keep going. So all of these are going to look very similar. We're going to have some polynomial where we got to figure out the zeros. And we can see them here, here, and here. So this one looks to be even multiplicity at minus 3.5 or minus 7/2. So that's multiplicity 2. This one right here is when x is -1 of multiplicity 2. Since, again, it's just going to touch the graph but not pass through it. And this one passes through and has an x value of 1, so that's going to be multiplicity of 1 for that 0. So let's write our equation down. We have p of x. For minus 7/2, since that's a fraction, we can undo it and set it equal to 0. So multiply by 2. And then add 7 to each side, so we get 2x plus 7 for that one. For this 0 here, that's just going to be x plus 1. And for this 0 here, it's going to be x minus 1. And I encourage you, double check it once you feel confident with your answer here. Double check it by plugging in each of these zeros and making sure that the function does equal 0 when you plug those in using that zero product property. And now we just have to include our multiplicity. So this 0, or this linear factor, has multiplicity 2, since it's just touching but not going through. Same for when x is -1, we'll need to square that. And this one here, for x -1, that's going to be a linear situation, so the multiplicity is just 1 for that one, which we really don't even need to write. And now looking at our answer choices, we know x -1 shouldn't be squared. We know that we need the other two factors to be squared, so it can't be that. Can't be that one either, and this one matches up with what we had. So it looks like choice letter D is correct there. And let's just do one more problem. We'll do it a little bit quicker, since in reality you don't need to write the equation every time, since we just have multiple choice. Now it's better to understand it from those basic principles when you can write the equation for yourself, but since there is multiple choice, we can do this faster once you feel like you have the basics mastered. So let's start with the zeros. Goes through there, there, and there. We know this one is when x is 0. The multiplicity is 1 since it goes through it. This one here is when x is 1. Same multiplicity as when x is 0. And this one is going to have multiplicity of 2 since it just touches and then turns around. And that's for x is -2. So write that as multiplicity 2. And notice all of the linear factors here are already given for us, since it is multiple choice, so we don't need to come up with them ourselves, but you can double check that they make sense. So for this x equals 0, that linear factor is just x, and they have a 2 in front, which we can ignore since really that just scales it. It's going to make it steeper than if it was just 1. But it won't actually change the zeros. So we're just looking at x here, and we know it has to be linear, so it can't be b or c, since in that case it's squared, and that would mean that it would come down and touch it and then turn around. But we don't have that here. Now for x equals 1, that's the linear factor of x -1. That can't be squared, so that eliminates this one. And so that just leaves one possibility, but let's make sure this makes sense. So when x is -2, notice the square here, we do have multiplicity 2. When x is 1, we know that's linear, so that makes sense. And we know when x is 0, that's linear, so that makes sense as well. So choice letter A is the only one that actually makes sense with this graph here. And the simple reason for why we have multiple choice for these questions is that it is very difficult to determine if, for instance, these zeros are multiplicity 1 or 3, or maybe even 5 or 7. So having possible answer choices just eliminates the fact that it could be 3 or above for these odd multiplicities. Likewise for multiplicity 2, since multiplicity 2 and multiplicity 4 look very similar, one is more quadratic or more like a parabola, and the other is more quartic, meaning it's going to be just steeper when you look closer and closer to that x value. So because of those ambiguities when looking at the graph, it's better just to have multiple choice, which is why these questions have that.